Alrighty, folks. Tuesday. Did is it Tuesday? Uh, yeah, it's oh man, it's not been a great winter for me at all. So I should turn my music down. Sorry, hear that? I'm a pro. All right. So I'm wearing my wristbands so you all feel bad for me. I was in the ER again.
Oh no.
I kept them on just so you feel bad for me. So nothing got done at all. So, but anyway, hopefully your projects got done. And that's awesome. So project 1 was due 2 minutes ago. That was our first one, or project 0. I'm sorry, because we always start at 0. Yeah, thank you. The first project, aka project 0. So we're gonna talk about that tonight. We can talk about the lab real quick. That one's real fast, and then we're gonna get into new stuff, chapter 4, and we mostly skipped section 5. This is nothing you really need to worry about till later. It's interesting stuff, but section 5 is typically something we do in a more advanced class because it hurts your head sometimes, and that's okay. So we're not going to take advantage of any of that stuff, and it's just shortcuts. It's just a way to make things a little bit faster for you, but I'm going to skip over most of it. Section 6 is cool. Section 7 is cool. Section 8 is cool. So we'll do pretty much the whole chapter except for 5. Should be out there. We'll work on tonight, or at least get as far as we can, because I don't know. We'll see how it goes, and then we'll keep on moving forward from there. So let's talk about the project first, right? Did it go okay for you folks?
Yeah.
Cool. Yeah. Let me go edit this one here, and I'll start up IntelliJ. There we go. So again, I'm going to not do it in the private repository so that it's a public example. So I'll skip those couple steps, but you guys are getting good at that by now. I think this week I only had to help like 3 people get their stuff in the repository, which is good. That's an improvement, right? It's every week we're going to practice, and that's okay. It's a lot of steps. We just got to get through it here. And then again, working through this, kind of looking at the rubric, right? This is how we're going to score it when it gets scored, right? Based on did you do this? 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 On and on and on. So if you got some of it done, not all of it, that's okay. Right? It is what it is. If we did all of it, then we should get all the points here. But this, asking you to do a self-assessment, it's kind of scoring yourself. Did I check all the boxes I needed to check here? Okay. So we're going to help our contractor friend build their deck, or put together a quote for the deck here. So we start up a new project. Call this one project 0. Again, I'm putting it in my repository folder. That's right. That's where we want it to go here. A couple people have run into some trouble with GitHub because this box gets checked. Don't check that box. It shouldn't be checked. Sometimes it gets checked. I don't know if gremlins do it or if your cat did it or whatever, but don't check the box because GitHub and the GitHub Classroom workflow already makes Git repositories. What this box does is say, hey, I can make a repository first and then go tell GitHub about it. And then GitHub gets really confused. So don't check the box, okay? And we're okay. All right. And we'll go find our main. Here we go. And again, everything goes inside of our curly braces here in main. Lots of questions from folks. If you put stuff that's not inside these curly braces, it gets mad at you pretty fast, right? Again, starting today, we'll figure out what this is all about here, and then next week we'll figure out what this thing is all about. But for now, just pretend it's magic. Is that okay? Just start inside the curly braces. We should be okay. So, a couple things we need to do, right? Figure out the length and width of the deck, the length and the width of the board they're going to buy, calculate the number of boards required for the deck. Lots of ways to go about this. I think area is the easiest, right? Calculate the area of the deck, calculate the area of the board, divide the area of the deck by the area of the board, round up, because you can't buy half a board at Home Depot, right? Or if you can, let me know, because they keep charging me full price for boards if I only want half a board. Do any of you work at Home Depot? Is there a pro tip for that?
I used to work at Menards.
Do they sell half a board? Menards doesn't? Okay.
You don't work there anymore?
And you got to go outside out to their barn at Menards, right, to get the lumber. So anyway, so we'll go create a bunch of information, right? So enter the length of the deck, and now so you can cut it, but they will still charge you full price.
I'm not sure.
Okay.
They might, I don't know. I think they charge you to cut it instead of charging you full price.
So anytime we're dealing with units of measure, right, we should tell the user, because remember, users are us and we're dumb. I'm pointing at myself here too. What unit you want to use. So if you just say enter the length of the deck, they're probably going to tell you in feet, because that's the terrible system of measurement we use here in the United States. I might tell you in meters, because I like to be really obnoxious and do everything in the metric system because it irritates people, but it is a superior measurement system. And then I get to laugh at people because I'm using a better system, and that's my problem, not yours here. So either way will work okay. Yeah, hey, thanks for hopping online here. Yeah, someone had a grant, or it was a chart, and so it wasn't even our measurement system, it was the electrical system. Us, Canada, Mexico, and I think 1 or 2 other countries in like that Central America area use the 120 volt system or 110 volt system, and like the rest of the world doesn't. It's just such a mess. Like why can't we have standards? Yeah, yep, yeah. Gotta have adapters. So anyway, the length of the deck, I'm going to say in meters because I'm going to be obnoxious. That's okay. When I ask for the length of the board in meters, probably won't make a lot of sense because you're not going to buy a board that's 2 meters tall, sure, but not a meter wide. But that's okay. That's my problem, not yours. And again, as long as you stick to the same unit, it'll be perfectly fine. And then because this is meters, we're probably going to have decimal places, and doubles are easy for that, right? So we'll have a double. This is length of deck in meters here. Right? Again, feel free to use long variable names. You know exactly what this variable does because that's the name of it here. So it'll be double dot parts double given. I need a scanner here, right? So we need scanner. I like to call mine keyboard. The new scanner given system.in. I think the book uses. I forget what it even uses here, but that's fine. Yeah, his text IO stuff is obnoxious. That's all right. I will rewrite that soon. Back to my friend. Thanks for donating to the scholarship fund. Appreciate you, brother. So we got our electrical grid first. Why do we? I don't know. The whole history of that must be interesting. And I don't like typing a lot here, so I'm just going to copy paste. Right? We need length, width of the deck, length, width of the board, and we'll just go change a couple things here. So it says width of the deck, length of board, and width of board. Width of board in meters. Okay, so width of the deck, length of the board, and width of the board. So the only problem when you copy paste is sometimes you do it and forget to change things and you get confused. But that's okay. We'll just proofread it here. We'll just go in and see what it's doing here. So once I have those, I can calculate area, right? So you could make new variables for them, or you could do it all in one go. Perfectly fine. However you want to approach it here is going to work here. But I'm just going to say this will be my double number of boards required. Boards required is going to be, and I can do the arithmetic all right here. Right? Parentheses to force order of operations. Even if you don't need it, it's a good idea, right? Because you know what the order of operations should be. We might as well just make it explicit here. So I'm going to take the area of the deck, right, which is the length of the deck times the width of the deck. Right, take all of that, and here, let me bump this down a little bit here. We're going to divide that by, now this is where we do need the parentheses, right? Otherwise we get left to right. This would be okay, but I need to get the area of the board here. So my length of my board times the width of the board. Now all of that now will give me some number, right? So if the area of my deck was 200 square meters, right, a 20 by 10 deck or something, and however many boards I had, each board, I don't know, 2 square meters or something, I'm going to get some number, but I want to round up, right? And we did rounding before, so we throw all of that in math.ceil, right? Ceil for ceiling. So we just get all of that inside the math ceil set of parentheses, and I can click on either one of them, make sure they're lined up here, right? That'll round up to the number of boards required. Now, math ceil is a little funny because it gives you back a double, right? So we have to tell it it's a double. If you don't like it saying you need to buy 12.0 boards because that irritates you on the output, you're welcome to turn this into an integer. You can do that if you want, right? We looked at that casting as an integer. So if I say it's type integer here, it's going to yell at me. I get this red line that says required type int provided double, and a whole mess of stuff on the screen we don't even really care about here. But to say, hey Java, I really, really, really want this as an integer, you put in parentheses int here, and we're casting. We're saying, hey Java, treat it as an int, please. So if you like integers, go for it. Again, the doubles don't bother me at all, so I was just going to leave the doubles. But if you like integers, you've got that option here, and then your output will look nice and pretty. And then again, these should probably line up because we want stuff to look nice. That's the number of boards required, right? Then we're going to ask them the price per board. Okay, pretty straightforward. So again, I already have some input here. Might as well copy paste here. Enter the price of a board, and this will be price per board, right? Double parse double, given the input. Number of boards times the price per board gives me total board cost, right? Now, again, this should be a double here because, everything is $1.89 or something here. It's probably not a whole number. If you use an integer, I'm not going to mark you down at all if you assume prices come in whole dollars, but that's okay. We haven't got rid of the penny yet. This will be total board cost, something like that, is my number of boards required times the price per board. Okay, now we got the total cost. Now our friendly home improvement store, Menards, Lowe's, Home Depot, whatever, I don't know, Ace, do they sell lumber?
I don't know.
Okay, I don't know. They give us a bulk discount. So this part was confusing for a couple of people, and I apologize. I probably didn't explain it well. And again, the stuff comes out of my head. I type it down, and I talk about it. And sometimes there's a disconnect there. So thank you for asking questions. For if it wasn't clear to you, this is the discount we get on boards because we get a bulk discount. If you're going to buy $1,000 of boards, we'll just pretend they give you a 10% discount because they're like, thanks for your business. Great. Sure. I mean, you can get coupons. I think sometimes they have coupons for stuff like that. So why not? And if we're buying more than 2,000 in boards, we get 15% off. So the order in which we check these is going to matter. And a couple people ran into this when I was doing some meetings here. So if we just look at if statements, and I say, hey, if you bought more than 1,000, you get 10% off. And then I say, if you bought more than 2,000, you get 15% off. You're going to end up with the wrong discount because both of those are true, right? If you bought $2,000 worth of boards, it is more than 1,000 and it's more than 2,000. So some way when we're doing our logic, we want to make sure we're checking you either get the 15% discount or you get the 10% discount or there's no discount, right? So one of those three cases should happen, but no more than one of those three cases should happen. So depending on how you wanted to work that, I like it going top down, and I think that's probably the simplest here. So I can say, hey, if the total board cost is greater than or equal to 2,000, and again, just because we can, you can throw in these underscores for your digit separators. Highly encourage it because it makes your code a little easier to read here. If you don't, no big deal here. It's not, no worries. So if your total board cost is greater than or equal to 2,000, let's take the total board cost. Now, a 10% discount means it costs 90%. Right? Again, however you want to do that arithmetic is perfectly fine. I can say times equals 0.9 if you like your shortcut notation. Multiply it by this and assign it back here. Right? 8.5, yeah, 8.5. Thank you, little birdie. Yeah, you got to catch me when I do dumb things. 15% discount. Yep. So if this is true, great. Now what? So if it's not true, else if my total board cost is greater than or equal to 1,000, and we can add our digit separator. Now you get the 10% discount I was talking about here. Again, why not copy paste? 0.9. Else, you don't need it. There is that third case, but I'm not changing the board cost if neither of these other two are true. The question?
For the total board cost, shouldn't it be greater than 2,000 and less than 2,000?
So I'm checking if it's greater than 2,000 first.
Oh,
so I'm going to say if it's greater than 2,000, this block runs, and then because when you chain these together, they're mutually exclusive, this gets ignored because it's part of the else.
Yeah.
So you could say if.
I wrote it the opposite way, so I included the.
Yep.
I started with like.
Yes, you could say board cost greater than or equal to 1,000, and total board cost less than 2,000.
Yeah.
Right. You definitely do it this way with separate ifs because this one is putting that range together. Both of these must be true for this to happen. Yep. Yeah, and that's there's like 7 different ways we could write any of these. Perfectly fine. You could even have done a switch if you wanted. Switch total board cost 1,000, total board cost 1,001, case 1,002, case 1,003. That was mostly a joke, but you could if you really wanted to here because switches are awful. Yeah. Calculating the area of the deck and boards beforehand more organized. Okay, yeah. Lots of different ways of going about it. So that's our board cost. Right? Either you get this discount, you get this discount, or nothing. You don't always have to have that else, right? If there is nothing that happens in a default case where this isn't true and this isn't true, we don't say anything. If you wanted to put out some messages here, that's a nice friendly thing. Hey, thanks for buying so much, you get a 15% discount. Or hey, thanks for buying so much, you get a 10% discount. Or hey, by the way, if you buy more, we'll give you a discount next time. You always got to be upselling, right? What are the ABCs? Always be closing, or that's not selling, but whatever, right? The cashiers, you want to open a Home Depot card? I feel so bad. Apparently they get tracked on how often they ask people. And if they don't ask, they get in trouble for it. Really, we're going to punish our poor cashiers who barely get paid anything anyway? Well, so that's a safety issue. And I can understand companies saying, please don't stop thieves because we don't want you to get hurt. We don't want the liability. Just let it happen. Like we've got insurance for that sort of thing, I can understand that, right? I mean, some people might want to go after them, but that's okay. My mother-in-law used to work at what's that candle store, and they sell soaps and candles. No, the Bath and Body Works. Yeah, she used to work there, and she gets so pissed off when people would steal stuff. But she's like, the company won't let us say anything about it. I was like, yeah, so you don't get hurt. You're like a sweet old lady. I mean, my mother-in-law's not old. I didn't say that. Apparently, there's like an organized ring of people who do this, and then they just eBay the candles because they're like $30 candles, and they sell them on eBay for $10. Anyway, we're off topic again here. All right, so now we're going to ask them for their time estimate and how much they charge per hour. Let's get the labor cost. And I think this is where the big confusion was. There's two different discounts. One is on materials, one is on labor, right? You can offer a discount on your labor. Be like, hey, I'm doing this job for a friend. I'm going to give you 20% off. Or, hey, I'm not giving you a discount because you irritated me. Sure. I mean, it's totally up to whoever runs the program. You want to give them a discount, yes or no? And then what discount are we giving them on your labor? Okay. So for time estimate and hourly rate. So two more prompts here. Again, probably doubles, because why not? So enter the amount of hours, right? Amount of hours you estimate the job to take. And this will be our hours. Maybe hours estimate. I don't know. Come up with any variable name you want here. Something with hours in it probably makes sense here. And enter your hourly rate. Sure. Something like that. This is our hourly rate. Probably good here. So then we'll have our total. We can calculate that. So, this is our labor cost. Is my hours estimate times the hours rate. Oops, I guess I did those backwards. That's fine. Still works out the same way. Now we have a labor cost. Now we can ask them, do you want to offer a discount? And then this is not a double input here. Right? So finally, we're doing something a little bit different here. So I probably won't copy paste. You want to offer a labor discount or a discount on the labor. And then when we're prompting people, it's helpful to tell them what we expect, right? It's not necessary, but it's helpful. So like Y or N. I say Y or no, and that doesn't make any sense. Y or N, right? Yes or no. Great. And then we'll get that input. So this input is as a string because it's text. So I'll have a string. So I don't know, discount. Yes, no. I don't know. That's ugly, but sure. Discount YN. I think you know what that means. Sure. It's just keyboard.next line. Just get the next line here. Now we're going to say, hey, if they entered, and we could either say if they entered a yes, we do something, else we do something else. We can say if they entered a no, do something, otherwise we do something else. Either option is perfectly okay. I'm going to go with the Y here. So we can say if discount, and now remember, you can't use the double equal sign here. That's no good because Java's dumb about strings. They'll never equal. Actually, sometimes they will, and it gets really confusing, but they usually won't equal here. So we always got to use this equals here. And the great thing about equals is it gives you the ignore case option because who knows if the user's yelling at you and like capital Y, yes, capital Y, capital Y. I don't know. Some people like to yell online, so sure. So I'll always do ignore case here. I'll say, hey, if it equals ignoring case the letter Y. So if they enter the Y, great. Now what discount are we giving them? Right? Ask them. So what discount are you giving? Now, again, tell them what you want them to enter. If you want to say 1 to 100, and then we'll assume that's a percentage. That's really nice and easy. If you want it as a decimal, say like 0.01 to 0.99, like 1% to 99%, that's fine too. You probably don't want them to enter the percent sign because if you tried using input and having someone enter a percent sign, it probably crashed on you because Java doesn't know what a percent sign is when it tries to convert to numeric values because it's dumb. So I'm going to say 1 to 100. If you want to give them 100% discount, go for it. Hey, I'll do the labor for free. You just pay me for the cost and maybe buy me some beer and pizza or something. Sure, we can work something out. Any way we want to go about this is fine. So I'll suggest 1 to 100 here. So maybe what percent? Maybe what percent discount? And then I'll just suggest 1 to 100 here. Again, we'll figure out ways later to avoid crashing if they do give us crazy stuff, but we don't know that yet. So it's okay. We're not there. Then I'll have our double here. So sure, we'll just grab one of these doubles. Discount is going to be double parse double, keyboard next line. Now, they probably entered an integer here, but maybe they said, hey, I want to give you a 22.5% discount. Sure. So either way is okay. And then I'm just going to take this and divide by 100 to make my life easy, because then I'll turn it back into a decimal. So if they entered 25 for a 25% discount, I now have 0.25. And just the arithmetic here, nothing too crazy. Okay, so great, we're giving them a discount here. So I'm going to change the labor cost. So I'll say labor cost times equals here, or again, any way you want to do this. This is just my shortcut. Now, I don't just multiply by the discount here, because a 25% discount means I pay 75%, right? Remember our back to math class? So I want 1 minus the discount here is what I'm multiplying by. So 1 minus 0.25 will give me 0.75. You're paying 75% of the labor cost. That's the 25% discount. Again, if you got the arithmetic wrong, it's not the end of the world. Like, it's not a math class, we're a programming class, but these sorts of things sort of work like this. And that's it. If you didn't enter a Y, there's no discount. I don't have to change the labor cost. That's it. So at the end here, then, calculate the total cost for materials and labor, output the total cost. Great. So we can spit it out. So total material cost plus my, total board cost and total labor cost plus the labor cost, sure, and grand total is, now I'm going to force order of operations here. If you don't force order of operations here, you're going to get some really funny output, because remember, Java goes left to right. It would say, hey, here's a string plus an integer. You really want that as an int. Let me turn it into an int. Hey, here's a string plus an integer. Let me take this integer and stick it on here. It would just give you the numbers stuck together like string concatenation, not like integer addition. So with the parentheses, we'll get the right thing here, plus the labor cost. Okay? And that's our project. Let's give it a run. So let's check the rubric, right? Did we get the desk? You guys are bad at checking me. Did you build a desk for people instead of a deck? Sure. Length and width. Get the board length and width. Calculate the number of boards required. Okay. Cost per board. Apply the discount. Great. Customer labor discount and apply. Great. Total cost at the end. Awesome. So it doesn't technically even need these 2 lines here. I think that's nice to show people, right? I always like to see that when I get estimates from people. So let's right click and run. So what we need to be able to do to check our program is know what the output should be here, right? So we got to think about it for a second to know what we're going to plug in and what should come out so that we can check our program, right? If we don't know what's supposed to come out, we've got no way of knowing if we did this right or wrong here. So let's just take just a second and think about it here. So if we build maybe a 10 by 10 deck, that's pretty easy. That's 100 square feet or square meters, right? Because we're doing meters, right? And if I get boards that are 1 meter by 1 meter, because again, I just want some easy math here, right? So 1 by 1 boards, I should need 100 boards, right? If boards cost $1 per board, that should be $100 in boards, no discount here. Again, we'll get to some of those other ones later where we try and do some of those discounts here. And then we'll ask for labor. Let's say, hey, maybe this is going to be a 1-hour job, and we charge $10, and we'll say no discount. So it should be $110. Right? And we want to think of different ways that are going to use all these different things. So we'll come up with another scenario, right? Sorry, that's really small. I think that'll zoom. There we go. So if we do another one here, let's do a 10 by 10. Let's make this bigger here. Let's do maybe 30 by 30. Why not here? 30 by 30. So that should be 900 square meters here. Again, 1 by 1 boards is probably easy, but if we wanted to change it up here, let's do 3 by 3 boards. So it should be still 100 boards, right? 900 divided by 9. So let's make our boards cost a whole lot more money here. So if they're $20 each, that should put us right at the 2,000 mark. We should get a 15% discount, right? So that should be 15% off of 2,000. Should be $300 off. Should be 1,700 for the boards, right? 1,750. Right? I think 10% should be 200, and then the 5% should be 100. That should be 300 off. Yep. Here, let's check the calculator. 2,000 times 0.85. Yeah, 1,700. Yeah. All right, and then labor costs. Let's sure, $1, $10, but let's give them a discount here. Let's give them a 10% discount. So we should have $9 worth of labor here. So 1,709 for a total. Again, just come up with some inputs, see what we get, and then we also want to test the 10% discount. We come up with another scenario here. You get the idea, right? We want to make sure the code actually works. So we need to know if I give it this should come out. Right? We need to be able to think through that. And if you can't do this part, you probably didn't write the code right, because you need to know if something goes in, this comes out, right? To understand the problem for us to be able to make Java solve it here. So length of the deck. Let's do the 10 by 10. So 10 by 10, 1 by 1, $1 per board. We said 1 hour. We charge $10 an hour. No discount here. $110, $110. That was good for our first try. All right, we'll try the other one. So we said this was what, a 30 by 30, 30 by 30 with a 3 by 3 board at $20 a board. Okay, I don't know, 1 hour again, we charge $10. Yes, we want to offer a discount. I will give them, 10% discount here. Labor cost is 9, right at the 10% discount. Great, 1,700 for the board, 1,709. Looks like it's working so far. Yeah, we can come up with other tests, and you don't need to go crazy here, but you want to make sure that essentially anytime you've got something that could happen, you're making sure it does happen. So we made sure that we got the 15% discount. We should make sure we get the 10% discount, right? We made sure we got a discount, and that worked out. We made sure we didn't get a discount, and that worked out. So just working through making sure our program is correct here is important. That idea of, does it do what it's supposed to do? Okay so far? All right, awesome. So let me go get this committed to GitHub here. That was project 0, 1500, winter, project 0, and push. All right. I gotta fetch first. I changed the README file. I added the links. I don't know if anyone actually goes out there ever to look at it, but just for fun because it entertains me. And the syllabus I posted into the GitHub repo, I won't go and put the links in here too. And so they're on D2L and they're here just for fun. But I forgot to do it for 2 weeks. So okay. So we're gonna move into chapter 4. We're gonna talk about the lab, then we'll move into chapter 4. Okay, talk about chapter 4, and then we'll talk about project 1, and then we'll get out of here because I don't feel so good. All right, it's not contagious. It's all GI stomach troubles. You don't. Sorry, it's probably too much information. All right, awesome. Yeah, we'll have a lab for practice today. Just a small practice, like we had the lab last week was a small practice with loops here. The project will use loops and subroutines. And we'll kind of keep on building here. So just like math class, you don't ever get to forget anything you've done before. Everything builds on the stuff you've done before, which, like we talked about, if you're getting behind in the class, just causes all sorts of trouble because it will pile up real quick. So I've heard good news from the tutors. A couple reached out and were like, hey, we worked with one of your students because I know most of them by now. And I was like, yeah, thank you so much. So the tutoring page is up there. And now there is a tutor out at Auburn Hills who also tutors remotely. So they finally fixed that schedule here, but it's not in. I don't know why our website doesn't work. It's the website down again every week. Every week. Okay, but the Auburn Hills schedule, it's there, but you have to scroll all the way down to the bottom of the page because they didn't alphabetize the departments. So CIS, because it was the last edition, is at the last bottom of the page. So you can do appointments there, and I think he has Saturday hours, I believe, which is great for some people who are busy during the day. So take a look at that. And Ancient Bags, you want a dad joke? That's right, because we have just spent a lot of time talking about Java, so we will do a dad joke here. I got you. I ordered a chicken and an egg from Amazon. I'll let you know. That was pretty quality. What you got?
Did you know that diarrhea is hereditary?
Hereditary?
It runs in the genes.
Oh, yeah, there we go. Going with the poop jokes. That's classic dad joke material. You have to laugh at your own jokes, right? All right. So hopefully our website works at some point here. But the worse the joke is, the more funny it is for dad jokes, right? They're supposed to be terrible. If it's actually a good joke, it doesn't count as a dad joke. All right, so we're gonna talk about the lab next. That was our. I didn't make any changes. What are you talking about? Our quick practice with loops here. So for labs, I am going to start putting them out to 11:59 p.m. instead of 6 p.m. Please don't wait to start them until the day that they're due. Like the goal is that you get them done that night, or if that's okay. If you got to walk away and get some fresh air and come back to it the next day, that's fine. But like, don't not start on it until the next week, because then you're further behind, right? But if you need to work on it throughout the week, that's perfectly fine. That's okay. I know 4 hours straight of Java is a lot, and that's okay. So if you got to take a break and come back to it later, that's okay. But if you have last minute questions, right? I only have like 2 hours of office hours before class. I don't want like a whole pile of people trying to get questions answered, and I can't help everybody and that sort of thing. So if you have any last minute questions on the labs, bring them. That's okay, and we should be in good shape there. Again, The goal with these is that you can get them done with minimal help. Generally, that's the goal. If you're understanding of what we did in the week, if you did your reading, did some of the practice stuff, the lab should be relatively doable, right? Without too much trouble here. The projects are going to kind of stretch you a little bit. You're going to try and put it all together here with less guidance. I think is sort of the idea there. How do you apply all the tools and techniques and things? So this is lab 3. So I'll start up a new project for this. And then I'm going to try and go over them every week as well to kind of answer any of those questions you might have had, but should be okay here. So lots of different ways of doing this to calculate the average score of a test, right? When we talked about loops here, if you know how many times you're going to run your loop, you could use a for loop. That's what for loops are really good for, right? If I can start a loop, it'll run this many times and I'll stop. If we want to use some sort of like sentinel value, like say, hey, enter a test score or a particular invalid value, I'll know that you're done. Just keep on going until you're done. That's nice and easy because I might not know how many tests are in my stack. And if you have to tell you there's 23 tests here, well, I've had to do more work. And that's okay. There's nothing wrong with that, but it's just a different approach. And you could also do a do loop because you could probably assume that they'll have at least one loop or one test to enter. Otherwise, why would they run your program? Right. I think any of those are perfectly valid here. I'm going to show the while loop method. And I'll also do the for loop method as well because they both work out pretty well here. It should be okay. So get this ready here. So if we're just jumping right into enter a test score, or it's like -1 is probably a good invalid value because it is possible to get 0 on a test, right? That's possible. Shouldn't happen, but it's possible, right? So 0 is not a good value to say, hey, enter a test score, or 0 to stop. So pick something else, like -1 or like 1,000. I don't know. Any sort of invalid value that you want to pick is fine as a sentinel value. Just tell the user what to do. So we're going to set up our scanner. We'll call it keyboard as a new scanner. Give in system in. And then if we're going to be adding a bunch of values together, we need a place to add them together. And if you declare a variable inside of a loop, it only exists inside the loop. So I need something outside the loop that I can add to, so it will exist when the loop is done. So I'll have probably a double here because we're going to do some division. I want to make sure I get my decimal places. Here, this may be maybe my total score, and starts off at 0. Okay, and then we can ask the user. Right, we can say enter a test score or negative test score or -1 to stop. And then we'll get their score. So score can equal, or a double for score, can equal double dot parse double, given the keyboard next line. And while my score does not equal, while here does not equal -1, we want to keep on going. If it's not -1, take total score, add to it the score, and then prompt them again. Again, a little copy paste here. I feel a little bad about it, but not too big of a deal. And now Java's upset because it says you've already defined something called score. You don't need to tell Java it's a double again because we already told it it's a double. We're just giving it a new value here. That's all it is. Now, the other option that you can do here, and this doesn't always work, but I like this sort of trick here, is instead of having this twice and feeling bad about yourself, because that general rule of thumb, if you have the same code twice, you should feel bad about yourself, applies. I can kind of cheat a little bit here, and I can say, okay, you know what, I'm not going to prompt them here, and I'm just going to set score to 0, because 0 plus 0 is still 0, and then they'll hit the first prompt inside the loop here. So I'm going to give it a value that I know will make sure the loop runs, right? The loop will run, 0 plus 0, I don't change total score, and then, sure, they're going to enter a test score, we get the score. If it's not -1, we go and add it up, we ask them again, on and on and on. Now, the other thing we don't have yet, though, is how many tests have I entered? So we need another place. That's probably an integer value because you're not going to enter half a test. It's like number of tests. That one starts off at 0. And then every time this thing runs, we're going to go add another test. Now, the problem with this is we're going to count when they enter -1. Because if I enter -1 to stop, we get the score, we get -1. I've added 1 to my test. I come back up here, say, does score not equal -1? Well, no, if it is -1, does not equal is false, the loop stops, now my number of tests is wrong. So I could just start number of tests at -1. Again, tons of different options here, however you wanted to go about that. Other people were like, hey, let's check and say, hey, if score does not equal -1, I can add 1 to my tests. This is perfectly fine too, but it's another line of typing, right? So I'm not going to bother with it if that's okay. Right? I'm just going to kind of cheat and say, let's start at -1. right? Because I know I'm going to go and add 1 anyway. Is that okay? All right. And then when that's all done, right, I can spit out the average here then. The average test score is, and then I can append in here, do some arithmetic, my total score divided by number of tests. If you want to have another variable for it, go for it. Doesn't hurt anything to have a variable there. Or you can just do the arithmetic right in your print line. And that's it. So let's give this one a run. So let's enter 70, 80, and 90. The average should be 80, right? If I enter 3 tests. And again, we need to know if we feed it these numbers, this is what it should spit out for us to be able to even tell if our program's doing it right. Okay? So sure, we're going to say 70, 80, 90, -1, I want to stop. Average score is 80. I think that worked. Now the only issue we're going to run into here, and that's okay because the user is just dumb here. If they run it here and say -1 to stop right away, you get average test score is nan. Okay? That's not a number. A double divided by a 0 is technically infinity. If you take enough math, they'll tell you that's infinity. Infinity is technically not a number, so yes, this is right. But again, if they give you bad input, that's on them, right? And that's okay. It didn't crash hard on us, which is nice. All right? Questions, thoughts, concerns? So this is the while approach, right? Where I'm using this particular sentinel value of -1 because I know this is a bad test value, right? The other way of going about it here, which is perfectly fine, you could say, let's get a value for the number of tests. So I can prompt them, how many tests do you have to enter? And then we can have an int for tests to enter, right? Is an integer.parseInt of the keyboard.nextLine. Great. And I can say for, now remember 4 gets 3 pieces. You can set up a variable, you set up the test, and then you set up the update. So I can say int test number starts at 0. Test number is less than my test to enter. Now, this is going to look a little funny, starting at 0 and going less than. It'll make more sense later. But we always do it this way. If you started at 1 and did less than or equal to, perfectly fine. But once we start talking about arrays, you always have to start at 0. Like in programming land, we start counting at 0 because that's just a thing we do. But both work perfectly fine. It's going to look a little funny to you why I always start at 0 here. It'll take my test number plus plus. So this loop will run. Test number 0. It's less than the test to enter. It runs. At the end of it, right, we hit the closing curly brace. We come back up and add 1 to test number. If this is true, we run again. It's essentially a short way of writing a while loop. Because instead of having this on one line, this in my while loop, this at the bottom of the while loop, we put it all in the header here to make it nice and concise and make sure we don't forget things. Because in while loops, it's really easy. If you forget your number of tests or other sort of while loops, like if you're counting to a certain value and you forget to update that value, you have an infinite loop. You're less likely to have an infinite loop with the for loop because you've got it all right here. You're like, okay, starting at 0, less than this number, increasing. Sure. Right. The same idea, though, we still need a place to total all of the scores here. So this will be my, sum of scores. Again, just going with different names so Java doesn't yell at me. Starts at 0 here. So we'll go ask them to enter a test score. I don't need the -1 to stop. I just say enter test score. If I want, I can say for test number 1 or test number 2 or test number 3 if you want to get fancy. I don't think it matters at all. We'll take the score, and then we'll take our sum of scores plus the scores, or plus the score. That's it. That's all that has to happen in the for loop because this will stop itself once I've gotten to number of tests that I needed to enter, right? Because I increase this by 1 every time. When I'm done, again, I just do the exact same thing. Average test score is, and I can now use sum of scores divided by tests to enter. Again, just using different variable names just so Java doesn't yell at me here. Should calculate the exact same way. So let's try it twice now. Okay, so we had 70, 80, and 90, -1 to stop. Okay, how many tests we have enter? We have 3 tests to enter. 70, 80, 90, average score is 80. Right? Both ways work perfectly fine. Again, if you used a do loop, that's okay too, because it will run at least once. Like you're going to ask them at least once. Sure. Again, I just don't like do loops because you have a while and then a semicolon, and that confuses me. And things that confuse me, I tend to stay away from. That's just a natural human instinct, right? Stay away from the stuff that hurts. So we just do that. When does a dad joke become a joke? When it becomes apparent. Oh, I like that one. That's a good one. What do you call someone who tells dad jokes who's not a dad? A faux pas. All right. Okay. So here's the lab. Let me go ahead and commit this one here. So this is lab 3. All right. You want to take a break now before we jump into new stuff? Is that okay? We'll take 10. All right. Sounds good. So we'll put some music back. We'll come back in 10 minutes. And we'll pick up our new stuff. This is All right, welcome on back. Yeah, there's no way a McDonald's will open on campus, so we get refrigerated food. What it is. All right, so we're gonna move on to new stuff. This is week 5, right? Holy cow, 5. This is the book calls it Subroutines. I'm not actually fond of that as a name. Okay. So in Java land, we call them methods. So I'm going to call them methods because we want to try and keep that consistent. They've been called subroutines since this guy got into computers, and he's a lot older than I am because he's retired now, and he probably just never changed the name, and that's okay. So subroutines, methods, functions, you'll hear lots of different ways of talking about them here, but I'm going to refer to them as methods. So methods are fantastic. They let us do a whole bunch of stuff, and we've actually been using them this whole time without really knowing a whole lot about them. So println or println is a method. It's a subroutine. It does something. It's part of the Java library that does something here. So we don't need to know how to make letters show up on the screen. We just say println and we give it something and that shows up on the screen. So this idea that there's a method that does something, that's the whole concept. So methods just do some work for us. So we've used other ones too. So scanner keyboard equals a new scanner, given system.in. Every time I use scanner here, we've been getting some input, right? So we say enter your name, and then we say like string name is keyboard.nextLine. NextLine is a method. It's a subroutine. It goes and does something. What this goes and does is gets the thing the user typed, and it gives it back to me as a string. So like println doesn't give me anything back. I'm not going to say, hey, string something equals system println because it doesn't give anything back. Right? It doesn't return any values here. Java would be real confused, and it gives me a red line. It's like, no, it doesn't do that, right? But methods can return values, and we can save those values in variables. So we've done that, right? We've done parsing here, so we can say like enter your age, sure. And now with age, it's probably an integer. Most people, at least once you're past your kid years, you don't tell someone I'm 12 and a half. My daughter loves to tell me she's 12 and a half. She's very excited she's 12 and a half. But most of us, right, would just give a number. So I think integer is probably fine here. Integer.parseInt. ParseInt is a method, a subroutine. It does something. You give it some string, and it gives you back an integer, or tries to at least, or it crashes, right? So we've been using these methods this whole time here, not really knowing how they work. And that's okay. They're sort of like a black box. Java is an open source language. You are welcome to go and look and see how it does all this stuff. It won't make any sense, and probably at least until you've taken another class or two. Maybe it will, but if we go look now, we're just going to be confused, and that's okay. We're happy that it's a black box. I give it a string, I get an integer back. Fantastic. That's all we need to know. We don't need to know how it does any of that. I want the thing the user typed in. Fantastic. I don't have to figure out how any of that stuff works, right? Years ago, it used to be a lot harder to program because you have to do all this stuff by scratch or do all this stuff from scratch. That's a nightmare. We don't want to do anything from scratch. If it's already done, we want to take advantage of that and just use it because we want to solve interesting problems, right? I don't want to have to solve the problem of how do I get input from the keyboard. That's not interesting, right? So we've been using these methods this whole time. What we get to do now is we get to make our own methods. Now, when we write our own method, it's not a black box because we know exactly what it's doing because we're writing it. The idea is that if we write a really cool method and it's useful, we could give it to someone else. Now, that's real pie in the sky, rainbows and unicorns, because we're not going to do anything that interesting right now because this is your first class. Right? Let's just be honest. And that's okay. But one of the goals of methods is that they're reusable. Right? Whoever wrote parseInt, they're amazing, really smart person. Everyone uses parseInt. Great. We're not going to get there, but that's okay. So we're going to write our own methods to do something. So one of the things we talked about with loops was doing a validation loop. Give me a value that is valid, particularly with like numeric ranges. So if we wanted to go back to that example of, hey, give me a discount percentage between 1 and 100. If you want to give someone 100% off, go for it. If you want to give them 101% off, you're probably not going to pay them for the privilege of building their deck, right? So we're not going to bother with that. So we would do some sort of validation loop here. So we might say, hey, int for we'll just put it in a loop here. So we'll ask them here, enter a discount or percentage discount, right? Percentage discount, and we said 1 to 100. 1 to 100, right? And then we get that value. And I think I did mine as a double because I was going to do arithmetic with it anyway and divide by 100. So sure, that's fine. So we'll do double dot parse double. I'm sorry, this is the discount is double dot parse double given the keyboard dot next line here. Great. Now our loop, we're going to say, okay, while it is invalid, ask again. And there's lots of different ways we can go about this, right? Any different ways we want to define it is okay. I'm going to say, while it's invalid low or it's invalid high, is typically how I like to do these things. You could also say, while it's valid, and then wrap that whole thing up with not. Right? What is the valid range? And then if it's not valid, keep on going. Totally up to you, right? Lots of different ways of going about that. And we can write them both here for fun if you want. So I'm going to say, while discount is less than 0, right? You can't give a negative discount, or we shouldn't give a negative discount. I don't even know what that means, right? I don't want to pay someone to build their deck. That's probably not how you stay in business, right? Or discount is greater than 100. If you want to give them 100% off, right? Free labor, go for it. That's up to you. Maybe they're going to buy you pizza and a beer. Sure. But more than 100% off, and again, we're paying them to build their deck, we're in a bad place here. So if either of these is true, because we're ORing together, right? If either side of an OR is true, the whole thing is true, then the while loop will run. And we can say invalid entry, try again. And then copy paste this, throw it in. And we don't need to tell Java it is a double because it already knows it's a double. And just change the value of discount. So we sort of have the same thing here twice, but we also have some additional prompt. So that trick I had where like, let me give you a valid value that makes sure the loop runs once. I probably don't want to tell them that it's invalid the first time it runs. So again, it's just a style preference. If you want to skip this line, that's okay. You can just take them back to the prompt and say enter % discount. They might be a little confused, but they'll probably get the hint. But you know, up to you. However you want to interact with the user is okay. We'll go with it. So this is our validation loop, right? Now, if we have to validate a lot of numbers and a lot of ranges, and we're doing this often, it'd be nice to have some sort of method or subroutine or black box that does it for us, right? One of the goals of methods is that I want to reuse it, right? I use parse double all the time. I've said before, and the general rule of thumb, if you have the same code twice, you should feel bad about yourself. Mostly joking, but that's a good rule of thumb. So we could take all of this and turn it into our own method, our own little black box here that will validate some input, which is really cool. So to do that, we're going to go write a method. So methods now are these things inside of classes. So public static void main string args is a method. Other methods that we write are going to go at the same level as this method. So they're not going to go inside the curly braces anymore. They're going to go inside the class curly braces. And you can put them above, you can put them below. Java doesn't care. It's smart enough to figure it out here. So we can go either direction. So I'm going to go below here just to start. So I click down here and I can see, hey, the closing curly brace matches with the opening curly brace for public static void main. That's my little hint here. I know where this one went. So below this one, but still inside of here, I'm going to write a method. So I have public. Now, there's two kinds of methods, right? We said like print line just does something. You don't get any values back. Double dot parse double gives you something back. So when you're defining methods, you say public, and then until we get to the next chapter, everything is going to say static. And the book will talk more about that. It's okay. Everything is static until next chapter. It's okay. It doesn't mean anything yet until we get to the next chapter anyway. So public static, and then if I'm going to return something, what am I going to return? Right? Java is all set around these contracts. If I were to say, hey, this is an int for discount here, it gives me this red line and it says require type int provided double, because it knows double.parse double. If I hover over here, it says it returns its public static double. It's real small right here, public static double. It knows that it's going to give me back a double. So whoever wrote parse double told Java it will give you back a double, and that's how Java knows that you can't store a double in an integer. It's not magic. It looks at parse double and says, hey, you're going to give me a double here. Uh-oh, I'm in trouble. So same idea here. So we're going to define it. So this will probably be a double, right? Because we're working with doubles here. So I'm going to say public static double here, and then what do I want to call it? Like a variable name, it's a method name. So same naming rules, same naming conventions apply as variables. Give it something meaningful, start with lowercase, every next word gets an uppercase. So I'm going to say, I don't know what, ask for value in range. Sure, ask for value in range. Then it gets a set of curly braces, like our if blocks or our while loops or anything. It's a block of code here. Okay, Now I'm going to take all of this here, and I'm going to cut this out. I'm going to throw it inside of here. Now, you notice keyboard.next line got lit up right away. It says cannot resolve symbol keyboard. When we first started talking about if blocks, we mentioned briefly that if you create a variable inside an if block, it only exists inside that if block. That's actually true for all blocks of code. So a variable created inside this block of code only exists in the main block of code. I have a new block of code over here. I have a new set of curly braces here. This is a different block of code. It has no idea what a keyboard is because it doesn't exist in this block of code. So for now, we just copy paste, right? And that's okay. There's other ways to go about this here. I don't recommend the other approach. So just do it this way. It's probably easier here. Just create scanner inside this block of code so that you can use it in this set of curly braces. Now it exists because I've told Java, hey, I want something called keyboard. It doesn't care that I have it here twice, and it doesn't care that they're both called keyboard because they're in separate blocks of code. It gets to be a little confusing here because now we have more than one variable called keyboard. It'll be okay. Just if you declared it in this block, use it in this block. If you declared it in this block, use it in this block. Okay, so now we can do this. So when we're done then, now it's giving me a little red line at the bottom here, and it says missing return statement. The keyword in Java to give a value back is return. We're going to return the discount. When this block of code is done, it'll return the discount. So what I can do with this now is I can use it just like a integer.parseInt or double.parseDouble sort of method. I can say, hey, my double discount is equal to ask for value in range. Whatever this double I get back from this return statement is, I'm going to assign to discount. So when I say ask for value in range, it will jump to this part of my code and run the entire block from top to bottom. If there's a loop in here, the loop runs. Right? It does all the things that code usually does, but now we're essentially jumping to this name, jumping to this method that we wrote. So if you don't read it here, if you just say, hey, ask for value in range, you get an idea of what it's doing. If you want to know what it does specifically, we go read it. Right? We can go and read it here. So methods put names to chunks of code, to blocks of code. It's another value of methods here. It can be a little difficult to follow if you've got 100 lines of code and you just have to read line. That can get a little tricky. So creating a method takes a block of code and puts a name to it, which is kind of nice. So it makes reading things a little easier sometimes. It kind of separates and breaks things down. One of my favorite technical terms out there is called functional decomposition. You take a big problem and you break it down into smaller and smaller problems. I can solve a small problem much more easily than I can solve a big problem. Right? The small problem I'm solving here is how do I get a number 1 to 100? Sure, that's what this does. It gives me a number 1 to 100. Excuse me. Oh. No, it's not going to kill me. It's just real uncomfortable. At least that's what the doctor said. All right. So I have a nice name to it, and then I can reuse this anytime I need a number 1 to 100. It's kind of fun, right? I mean, I don't know how often we're going to ask for numbers 1 to 100, but we could. And it depends on our particular programs, those sorts of things here. But now we can get this block of code to run when we ask for it by name. So the next cool thing we can do with methods is we can give them value. So like when we call parseInt, you have to tell it what it's converting, right? We put something inside the parentheses. In our case, we're just handing it the keyboard next line directly. We're saying, hey, whatever they typed in, here, have it. Right? I gave it a value here. So what I could do here is I could say, hey, maybe I don't always want it to be between 1 and 100. Maybe I want you to tell me what the lower bound is and the upper bound is. Right? So we can have that. So I can say double lower bound. So you tell Java what type of value it is and what I want to call it inside my method here. So as soon as I've done this now, I can now have access to something called lower bound. Lower bound is a double because when you call this method, you're going to give it a double for the lower bound. So I can use lower bound instead of 0. I can say, hey, if the discount's less than the lower bound, it's now invalid. Right? Well, what if I want to give it an upper bound? You can comma separate. You can pass. I think there probably is a limit. Maybe like 16 values. I forget what it is. Let's go Google it. Why not? Java max number of method arguments. 255. If you've got that many, you've got a problem. right? That something's gone wrong here, but sure. So this technically has two names, and it's really weird. So when it's here in the method, this is the method header or method definition. This is a parameter. We're defining a parameter. When you go and use it here, when it says, hey, ask for value and range, notice it's in red lines now. It says, ask for value and range in main cannot be applied to nothing. We're missing a parameter. It wants a double, so I have to give it something that's a double. Well, okay, well, let me give it 1 actually here for my lower bound. Now, IntelliJ tries to be helpful. It's showing you the name of this parameter right here. So it says lower bound :1 to tell me that this is the lower bound. When we did that like string equals, it said another string because that's the name of the parameter in the method for equals, ignore case, or equals. It's just trying to be helpful because usually these names are useful. If you put LB for lower bound here and use LB over here, it says LB and you're confused. What the heck is an LB? I have no idea. I mean, I might remember for a minute that it's lower bound. This is why good names are important, right? Use good names, don't use trash names, right? You want it to be useful. So if you want more than one value, right, I'm just going to comma separate. Hey, I want another double for the upper bound. And now I have to give it another number here, so we'll say 100. And then if it's greater than the upper bound. Cool. So now my ask for value and range, I tell it what the lower bound is, I tell it what the upper bound is, and the exact same code runs no matter what those values are. Right? So now I can get a number 1 to 10, I can get a number 1 to 100, I can get a number from 50 to 89, I can get a number from 2020 to 2027. Anything that I want that has an upper and a lower bound, I can use this method for. Right? I've created a nice little reusable piece of code. And again, probably not all that useful, but it serves its purpose. It will do this validation for me. Right? Now, this only works for discounts, and I said 1 to 100. Oops, we should fix that here, right? So enter discount, right? And then from plus the lower bound plus 2 plus the upper bound. This is probably prettier, right? So enter a discount from something to something. So if our contractor friend says, hey, make sure I don't give them too much of a discount here because I might have been drinking too much. Sure, we can put that in our code. You can't give more than a 25% discount now. We're going to protect you from yourself. Sure, we're going to be helpful for our users, that sort of thing. Go for it. I'm giving terrible examples. I apologize. I'm in a really weird mood here, but sure, okay. Just go with it, right? It made sense, right? Wasn't crazy? Might have been crazy. It's okay. All right. Now, it only works for discounts, though. Oh, we got to change this prompt here again, too. Oops, we'll change that one. Now, wouldn't it be nice if we could have this work for other things that aren't just enter a discount? Well, sure. If the only thing that's different is a value, we can ask for it as an argument. Right? So I can say, hey, give me a string. Oops. My goodness. String for the prompt. And I can just say, here's my prompt. So whatever string you give me as the prompt, I'm going to stick in here, plus the lower bound to the upper bound. So if you say, guess a number from lower bound something, upper bound something, this function will still work. This method will still work. This subroutine will work, right? Because I've now changed the prompt, right? Sure, that works. And to your age, we might want to bound, right, between 1. I mean, well, 1-year-old's probably not even typing either, but it's the age of a person. Do I want 0 to 100, 0 to 110? I mean, put some range on it. Sure, go for it. Right? We can use this for any sort of input here where we need to do some bounds checking. And it's useful now. So now, again, it's giving me a red line here because it says, hey, ask for value and range, string double double in main cannot be applied to int int. Looks really awkward here, but it said you gave it int int, it wants string double double. Okay, well, sure, let's give it a prompt. Enter a discount or percent discount, comma, and we just comma separate these things, right? And you can have a bunch of them, up to 255. Again, that's too many. Don't go to 255 because that who knows what's happening there at that point. But you can go and add as many of these as you want here. Other types of functions, right? So public static, right? We're always going to do public static. Again, We'll get back to why those words matter later, just public static everything. If you don't return a value, you get a special keyword called void. You're a void method. You don't return anything. It's just special for I'm not going to give you anything back. That's all. That's just what it means. So maybe this is, I don't know, say happy day. And we'll say, you give me a string for the day. And we just print happy plus day. Sure, why not? In our program then, instead of hello world, we'll say happy day, Tuesday. Right? Again, not the most interesting function, not the most interesting method here, but you tell what day it is, it'll say happy that day. They don't have to be super interesting here, right? It can be one line. That's okay. Java doesn't care. We're just putting a name to a block of code. If you want it to take arguments or parameters, oh, that's right. So this is a parameter. When you give it something, you give it an argument. So arguments match the parameters. Most people I know who program call them arguments or parameters, and no one blinks an eye. Like, we don't get into debates over, oh, you should have called it the other thing, because no one cares. So some people just call these arguments, some people call them parameters, some people call these parameters, some people call these arguments. No one cares. Right? This is not a big deal here. But technically, this is the argument. The argument matches the parameter. So in the function, in the method, it's a parameter. Sure. I don't know. Some people go nuts over stuff like that. So we can tell it to print happy day. It doesn't return anything. It's a void method. It just does something and stops. And we could, make a song out of it too. Happy day, happy day, happy day. What? Oh, happy day to you. Okay, sure. Doesn't have to make sense. Okay. I'm having a hard time, friends. Having a hard time. Sure. Whatever you want it to do, it's just a block of code that runs when you ask for it by name. Say happy day. We'll do say happy day. So it will jump. So when we're debugging here, this is the fun part here. Hey, PJ Buttercups, thanks so much for tossing your Prime sub here and donating to the Student Scholarship Fund at the University of Michigan Dearborn College of Engineering and Computer Science. Whew. Man, that's a lot to say. Remember, debug mode lets us see what's happening line by line by line and run things line by line by line. The debugger is your best friend here. Don't click run, click debug, the little bug here. We're actually going to watch it jump, which is really fun. So I'm going to step. Now, I had said before, usually you want to step over. If you want to go into a method, usually you want to step into, because you want to go into that method, right? So just step over, it will run and be done. So I want to step into, and now you'll see it jumps. So now my current line here is 22. So it went from here down to here. And it's actually tracking it. So you can see that on the left-hand side here, this is known as the call stack. Doesn't matter all that much. You'll learn more about that later. But it says, hey, I was at main line 9. I was here at line 9. Now I'm currently here at line 22 in set happy day, or say happy day. So you can see that it tracks where it needs to go back to. So it sort of just leaves a bookmark there. Yeah. So I wanted you to be able to pass it a string value for a value for day, because I can reuse this on Monday, I can reuse it on Tuesday, I can reuse it on Wednesday, reuse it on Thursday, reuse it on Blur's day. I used to say every day is Blur's day lately. So any string that you give it, I'm just going to assume that's the day of the week. So you could give it apple, and I'm going to say happy apple. The function, the method doesn't care, but I'm assuming, it says say happy day, you'll probably give me a day here. There's no good way to check that, but it just says if you give me a string, I'm going to call it day inside of my method here, and now I have a variable called day. Currently its value is Tuesday, because I gave it Tuesday when I called it. I gave it the argument of Tuesday. This is just so I can say happy day and give it different values. So string is the type that it is. So it's a string of characters. Yep, just like strings or doubles or ints or floats or anything here. Yep. And then day is just my variable name for it inside the method here. Right, and then we can watch it. It'll do these things, yada, yada, yada. And then if we go, remember, you get the debugger tab, you get the console tab. You got to flip back and forth sometimes. Happy Tuesday, happy Tuesday, happy Tuesday. Oh, happy day to you, happy Tuesday. Sure. Now we get this curly brace. This method is about to be done. We can step. We go back to main. We were at line 9. Now we're at line 11. It's just going to keep on going, right? So we run through this stuff. When you get to the next line, remember debugger looks like it stops working. It's waiting here for you to come back to the console and type something and say Eric, right? And then it picks it back up where it was. Your age, 35. Enter, ask for value and range. Let's step into, right? We go in here, we get our discount. Okay, now it's waiting for a discount here. Let's give it something invalid, so like 0. Sure. This is true, so the while loop runs. Say invalid entry, try again, please. Enter a percent discount, 1 to 100. Let's give it 25. The while loop is no longer true. We're going to get back, we're going to return discount. We return discount. Now, my value of discount here, right, is 25. My variable for discount. Notice all these other ones went away. I guess there weren't many other variables, but anything defined inside this function here and inside this method goes away when it goes out of scope. So scope is our technical term for that. If you're no longer in the curly braces and you created something inside the curly braces, you're out of scope. You no longer exist. The Java virtual machine at some point in time will go give the memory that you were using back to the operating system. It's a whole really cool process. I honestly don't understand how most of it works. But it says if you're not watching this variable, if you don't actively use it and it goes out of scope, we'll give the memory back, which is good. We want other pieces of the computer to be able to use that piece of memory. Otherwise, if we hang on to it forever, it's called a memory leak, and bad stuff happens, and then the computer gets sad. So lots of fun stuff. That was our program. Okay, so we can watch it happen. We can look at the different functions, the different methods that are running, and walk through them. So we can use all sorts of different ones here. So kind of a fun example here, and we're gonna try this, I think, for our lab here. There's a lot more to methods here, but I want to go through an exercise first, and then we'll see if we can actually flush it out here. So I'm going to start up a new project for lab 4 just to get some ideas going here. So I mentioned this idea of functional decomposition, right? How do you make a big problem and turn it into a small problem that's easier to solve, or lots of small problems that are easier to solve? So imagine we were going to play rock, paper, scissors, right? Just in English, what sort of steps do we need to do to play rock, paper, scissors? So we're going to play against the computer, and they'll pick randomly, and then that'll, that way you can entertain a small child for several minutes. Actually, I found out playing rock, paper, scissors on a computer. I wasn't expecting several. I was expecting like 30 seconds, but several minutes. I was quite pleasantly surprised. It's like, yeah. Well, so just in English, so forget Java for now. Just what do we do in English to play rock, paper, scissors?
You look at somebody and, hey, you want to play rock, paper, scissors?
Okay, well, so we sat at the computer. We know we're going to play the computer. What do we have to do if the human is going to play against the computer?
You gotta, like.
Sure. So we need to ask the user to enter rock, paper, or scissors. Sure. So we'll say, hey, I'm going to string for player throw. Get players throw. Sure. And now Java's upset at me. It has a big red line. It says, I don't know what a get players throw is. Sometimes these suggestions are helpful. Sometimes they're not. In this case, this is going to be really helpful. I'm going to click create a method. It says public static string get players throw. Now it says private. It's okay. Don't worry too much about it. I would say everything should be public just because it makes our life easier. We don't know what private even means yet, but sure, it's okay. Now we get a red line because it says you're missing a return statement. So for now, I'm just going to say return something and then leave myself a note to do this, right? Sure. So we got the players throw. What's the next step if we're going to play against the computer?
Well, we got to get the computer.
Sure. So string computer throw. Get computer throw. And it says, I don't know what this thing is. Sometimes the red light is helpful. Not all the time. In this case, yes, it's helpful. Again, I'm just going to return something for now because that's okay, right? And add a little to do this, right? Do this, sure. Whatever I said before, do this. Okay. Once I have my throw and once I have the computer's throw, what do you do next?
Countdown. Display them both.
Sure, we could do a countdown. We could display them both. But what do you actually want to know at the end?
The winner.
The winner. Yeah. So we'll say, I don't know, display, countdown, and winner. Now, to figure out who the winner is, remember, when we think about variables and their scope, player's throw only exists inside of this set of curly braces. So if display, countdown, and winner needs to know the player's throw, we're going to have to give it as an argument. So I'll say, hey, here's the player's throw, here's the computer's throw. I'll tell you these two things. You tell me, you display the countdown and tell me who wins, right? This doesn't need to return a value here. We're saying display it. So we probably expect this one to spit something out on the screen here. So I'm going to create a method. It accepts two arguments, right? It wrote that for me. Now, the names of the arguments don't have to match the names of the variables here, right? This is perfectly fine if this is A and B. Again, I should take that back. A and B are terrible names, but they don't have to match what we're giving other places, right? It's just the name for it inside your method here. The fact that they match, perfectly fine, because our program is all about playing rock, paper, scissors. They probably are going to match, and that's okay, but they don't have to, right? And then to do this. So in terms of functional decomposition, we took a big problem, let's play rock, paper, scissors against the computer, and broke it down into three small problems. First small problem, how do I ask the player for their throw? Next small problem, how do I ask the computer for its throw, or randomly generate a throw for a computer? Sure. Next small problem, how do I actually figure out who won? Right? Those are three different problems we can solve now separately, and it'll be a little easier here. Right? If I just want to say, hey, let's pretend for now that the computer always throws rock. Sure, that's perfectly fine. We can leave this in and fix it later. We can figure out, okay, let's ask the user for a throw. We should validate, right? Make sure they gave me rock, paper, or scissors, because lizard and Spock aren't valid unless you're playing rock, paper, scissors, lizard, Spock. Sure. And we should, in that case, we should tell them we're playing rock, paper, scissors, lizard, Spock. You'd be really upset if Spock disproved paper on you. You're like, wait, what? And it's just really confusing. So again, tell the user something, be useful, that sort of thing. Display. We could for now just say we could just spit out the throws. I don't know. We got lots of options on how we want to break this down and solve this bit by bit by bit. But what this lets you do is say, here was a big problem that was probably a little intimidating because I've never tried this before. Now I've got small problems to solve that are a little more approachable, right? A little easier for us to break down and do. Do you think we could do these for lab? Let's do a display countdown and winner, display a get computer's throw, display a get player's throw, and return those values, right? Sounds doable, right? I think that's workable. So this idea of using methods, now we haven't eliminated any duplicate code, right? Methods, I said, was good for that. That's not the only thing it does, though, right? So if I just look at my main method here, I sort of know what the program's going to do because I have nicely named methods. Again, this is a very small program, but this sort of idea, the main method doesn't need to have a lot of stuff in it. It can just call all the methods that actually do the hard work. So one of the goals and one of the things I like to do, and it's not a hard and fast rule or anything, it's just I like it, is I try and make main do nothing but call other methods. Yeah, okay, I've got a variable here, but I'm going to go give that to the next method. So that way I can quickly see, hey, in like 15, 20, 30 lines, it does this method and 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 does this method. Sure. If I want to see what the method actually does, then I can go look and see, oh, how did I go do that thing? Right, so it makes it a little easier just to look at a program and understand what's going on. Yeah? So display countdown on winner is not going to return any values, so we're not assigning it anywhere. We're just saying it will probably go and print a bunch of things to the screen. So this one will probably have a bunch of system outs. Yeah, this is just a placeholder. It will go when we call for it. It will go and run this block of code here. So we might say like rock paper scissors shoot or something. Rock paper scissors shoot, and then I don't know, someone wins, and that's our to do. Fix this, right? Display the right winner. Yep, the player's throw and the computer's throw. So you want this to be meaningful for the method. So display countdown and winner should be meaningful for what this is. So when you give me a string here, I know it's the player's throw, right? I don't have to actually give a player's throw. I can just give it apple, right? I can give it anything that's a string. As long as it's a string, Java says, okay, great. You gave it a string. A string matches a string. Fantastic. Inside the method, that string is known as player's throw. The variable name for it is player's throw. So I can use player's throw anywhere I want here. Right? We're not actually using it like, so player picked oh goodness, plus player throw, right? I can use that variable name inside the method, and whatever string you give me here, if you gave me apple, I'm going to say the player threw apple, and we're going to be really confused. But that's on me because I gave it apple, and that's my bad, right? I probably would give it the player's throw, and the player's throw method should go through and validate you actually entered the word rock or the word paper or the word scissors, right? We did some of that string validation last time with loops. How did I make sure you gave me a string that I expected? Okay, well, if it's not this string and it's not this string and it's not this string, ask again because you did it wrong, right? Hey, user at the keyboard, you typed in the wrong thing, try again. Sure, that sort of thing. We got lots of options for stuff like that. Does that make sense? So a couple other things about methods before we actually go and work on lab, because I just want to make sure we're hitting enough of the details here. There's a lot to it, which is really interesting. So this is parameters, right, or arguments, right? You can give it parameters or arguments here. Don't worry about overloading. We'll get to that later. This is more of an advanced topic. It is really cool that you can do this sort of thing. And Java is nice, but again, we don't usually get to this stuff till later. So read about it, but we're not going to do a whole lot with it. And then some of these examples, great. We didn't worry about arrays, so don't worry too much about arrays right now. Command line arguments, this string args, and we haven't talked about arrays, so it's not going to make a lot of sense yet. Don't worry too much about that one. And then we'll get to exceptions later when we get a little further in. Let's see. The lambda expressions, again, we'll get, this is more of an advanced topic. You can read through it. Don't worry if it doesn't make a whole lot of sense. It's just shortcuts, ways of doing things with less typing, which is everyone's a really big fan of. The Java packages, right? We've used math, right? Math has random, math has square root, these sorts of things. Have we gotten random numbers yet before? Okay, we got to do that then. So to get a random number, I'm glad I thought of that here. You say a couple different ways of going about it. The math one's probably the quickest here. You say math.random, and what math.random does is it gives you a double with a positive sign, greater than or equal to 0.0, and less than 1.0. You get a decimal number starting at 0, possibly, all the way up to but not including 1. So if I want a number from, say, 1 to 3, because I want rock, paper, or scissors, math random will give me 0. I multiply it by 3. Right? It will never be 1. So I'm going to get something now between 0 and 2.99999999999. Right? So I take that, and if I just treat that as an integer, this is a number 1 to 3. So this is actually bad. I've done a bad thing here. Because remember, order of operations, this happens first because they're touching. Then it will multiply by 3. So this will always be 0 because math random is never 1. So I want first math random times 3. So now I'll get between 0 and 2.999999999. And then say, hey, as an integer, get rid of the decimal place. I'll have 0, 1, or 2. Well, it's not 1 to 3 yet, but now I have 0, 1, or 2. I take all of that, and then I add 1. So this is sort of a formula for it, if you like formulas, right? So it's math.random times the upper bound, not including, or exclusive, or like you'll never get to this number, right? I'm sorry, no, I'm sorry, the upper bound, right, plus the lower bound. That's not right. And the upper bound minus the lower bound. Yeah, so it is the upper bound exclusive. This doesn't make a lot of sense for math formulas. I'm sorry. Sometimes math stuff is hard. But so if I wanted the number like 10 to 20, right, I would say math random. What is the upper bound exclusive would be 21. To get up to 20, I need 21 excluding 21, right? So a random number between 0 and 20, but I actually want that minus the lower bound. So if I want 10 to 20, I'm going to take 21 minus 10. That'll give me 11. Multiply math random by 11, I'll get from 0 to 10, right? And then if I add my lower bound, if I add 10 to that, I'll now have 10 to 20. That sounds a whole lot more complex than it actually is. So math random times 3 gives me 0, 1, or 2, plus 1 gives me 1, 2, or 3. right? And I can say like, hey, if number 1 to 3 is equal to 1, what? Well, the computer must be rock, right? If it's 2, the computer must be paper. If it's 3, the computer must be scissors, that sort of thing. Does that make sense? A little bit? So if you want non-zero starting or non-1 starting, you want to use this formula. Don't worry too much about it here. This one's pretty easy. And if you always want to start at 1, right? Sure. Here's your top number, add 1 to it. It works out really well. If you want other ranges, it's not terribly hard math at all, but it just takes a minute to think about. Math has always been the bane of learning Java. Yeah. There's other ways to do random numbers that might be easier. They take a little bit more typing. You can say random, an R name for it, random equal to new random. So there's a random class because math random is obnoxious, but it doesn't come all the time, just like scanner doesn't always come all the time. So you have to import it. It's in the java.util package. So I can say, hey, I want to import the class. It adds import java.util.random. So either approach will be fine here. So if you want to use random, go for it. Random has next int here, which is really nice. And you give it a bound. Here you say, I want 1 to 3. And you get a number. Now, trying to remember, does this one say the upper bound is exclusive? So you still have this exclusivity problem. So saying 1 to 3 will actually give you 1 to 2 because it excludes the upper bound. So you have to go 1 higher here. So next in 1 to 4 is a number gives 1 to 3. Either way, you've got to think a little hard about something, right? Whether or not you do math random or using this random class here, it's okay. The funny thing about this, right? It's not actually random, and I think hopefully that makes a lot of sense to you because you've been programming computers. They don't do things on their own. They do what you tell it to do. So someone told it to do something to make it look like a random number, but we can go look at that code and find out what it's actually doing, right? The way that it does it behind the scenes is basically it looks at what time it is, and it uses the time as a starting value for its calculations, because every time you run your program, it's probably a different time, right? No one has a time machine. So every time I run it, it's going to get a different, they call that a seed value for its random calculation. So it'll look like it's random, because every time I run it, I'll get a different sequence of random numbers, but it's pseudo random. It's not actually random. So don't use this for anything that needs cryptographic security. Don't use this for slot machines. There was a really cool story. Turns out, I think it was the Russians had a ring where they would go. They found a particular slot machine that was a video slot machine, and it would, as it would like loop through the different slot options here, the random number generator used to generate those images was the same one that it used to generate the actual output. So they would keep a little phone in their pocket, record the display as it's spinning here, feed it out to their computer somewhere, and it would tell them when to hit stop. And they were able to get actually make money off the casinos. So some casinos like, why are we losing money on our slot machines? Slot machines are supposed to make us money. Like literally, they're programmed to make you money. And they're like, why are we losing money here? This isn't right. And they did this whole tracking thing. There's an article in Wired. I don't want to see if I can find it now. Wired. Russia. Yeah, is this one it? From 2017? This might be it. Lumiere Place Casino in St. Louis. Notice several of their slot machines had gone haywire. Stop. I am logged in, aren't I? I'm logged in. Sorry. This is worth it. I promise. It's worth it. Yes. Sure. That's my. Come on. Never remember my passwords. I hate passwords. There we go. Come back to my article. Come on. There we go. Yeah. Government approved software that gives the house a fixed mathematical edge. So you can be certain of how much they're going to make over the long haul. Say 7 cents for every dollar played. That's interesting. I don't know. It's interesting. Is this? I'm sorry. I thought this was interesting. I've gone down a rabbit hole again. You guys got to reel me back in. Yeah. So random number generators. Right. If we know how they work, we can break them. So again, there are cryptographically secure ones, which I don't even understand how they work. Go talk to people with math PhDs. They understand that sort of stuff. It's really cool. I don't care. It works. So I'm happy that stuff works. So random numbers, we can do that. Where were we? Here. Math random. It's been a whole winter. A whole winter. So usually we import stuff. Cool. We import stuff. Yeah, we're doing that. Modules. Yeah, that's okay. This is all good stuff. JavaDoc. Some people love this stuff. When I took this class back as an undergrad years ago, because I'm old now, I got points off. Did I tell you this story? Because I didn't have a comment that conformed to the JavaDoc style that was required. My code did all the right things. It worked. It was flawless. I had no problems at all. And I didn't get all the points on it because I didn't have a comment. And I swore to myself, if I ever had a chance to teach this class, I would not require comments because that's stupid. It's not programming. And I still hold to that statement. Now, there's a point and a place and a purpose for comments. Okay, they're useful. They are useful for certain cases here. For our code, not useful. Right? I don't care. It's really nice when I say random.nextInt. When you get this cool big block of text, this is a JavaDoc comment. I'm glad they did this, right? If you're building a library for someone else to use, yes, please document it. Please do that. It's very useful because it's a library other people are going to use. For our class example code, we're going to throw away and never look at again because it's awful. I mean, it's fantastic. You guys are great. Just if you have to like save it and look back after you finish your degree, it's a fun experience looking at your code from your first semester programming. Always a good experience. Right? It's okay. We don't need to add comments. If you want to add the comments for your own purposes, fantastic. That's great. If you like to see that and be able to walk through it and think through it all line by line, that's great. Go for it. But again, I'm biased against them. So that sort of thing. But JavaDoc's great. You can do all sorts of cool things here if you give it a very particular format. This subroutine computes the area of a rectangle given its width and its height. The length and width should be positive numbers. At param, width, the length of one side of the rectangle. At param, height, the length of the second side of the rectangle. At return, the area of the rectangle. At throws a legal argument exception if either the width or height is a negative number. This would show up in that little pop-up when you go use this method in IntelliJ. Right? Our tools know how to read JavaDoc comments, which is nice. So it will tell you all of this sort of stuff in that little pop-up if you hover over area of rectangle. Right? I trust if you can learn to program, you can learn to write these. So I'm not going to spend any time teaching you how to do this stuff because I'm going to teach you how to program because that's the more fun stuff. Is that okay? All right, agreed? Cool. And then we won't talk about those anymore. Import static, that's all fine. All right, so chapter 4. I think we're pretty good. Program design, right? This idea, kind of building it out of step by step by step by step. Some people go nuts for preconditions and postconditions. I've never been a big fan of them, but the idea with a precondition and a postcondition is what must be true before this function runs and what's true after the function runs. The same idea, we said, hey, when I'm testing out my program for my contractor, if I give it this input, this should spit back out. That's the same idea. We're just kind of documenting it here in JavaDoc comments because why not? So sure. So to do whatever this open thing is, the parameters rows, columns, h, and w are positive integers. That must be true for this to work. If it's not true, you're going to get bad stuff. Right? If you give it negative rows or negative columns or negative height and negative widths, bad stuff will happen. Right? So we're just saying this must be true. Then postcondition, what's true after the fact? Well, a window's open on the screen that displays rows and columns of colored rectangles. Each rectangle is w pixels wide and h pixels high. Number of rows is given by the first parameter, the number of columns by the second. Initially, all rectangles are black. Sure. Right? This is what it does. This is what it did here. Okay. So if we were to think about that for ours, get computers throw, nothing has to be true beforehand. It doesn't need anything. There's nothing. There's no preconditions. What's going to be true after is you're going to get back rock, paper, scissors. That's the postcondition. Your return to value rock, paper, scissors. Not super interesting. For display and countdown winner, a precondition is that players throw and computers throw should be rock, paper, or scissors. If I give it apple, it's probably not going to do the right thing, right? If I don't meet that condition, who knows what's going to happen? That's sort of like the warranty, the disclaimer. Anytime you use someone's software, they're like, please read this 30-page thing and sign you agree to the agreement. No one reads those things. When I went to the ER, I had to there were 5 pages of these things. They're like, and I had to do it on my phone. They're like, hey, we'll text you a link to register. Like, scroll. No one reads that. Like, please treat me. Yes. Yes, I came here for treatment. Yes. Are you going to send me a bill? Yes. Am I going to cry? Yes. Sure. That's fine. Like, just say yes. The precondition and the postcondition is it displayed the winner. And that's what happened. What's true after we're done. So not super complex. Just another way of thinking about your functions and your methods. What has to be true before, and what's true after. So they're interesting, and you can do fun stuff with it. So here's examples. Declarations. So you can declare a variable, and then you can assign it a value. You can declare and assign at the same time. Or I like to call this initializing. For integers, it's not exactly the same thing, but that's okay. Do all these sorts of things. We haven't got to these class things yet, so I don't know why he does these sorts of things. But this you can't do. You can't assign a value outside of a function, outside of a method. You can when you declare it. And that's okay. I would generally consider this bad form, but that's okay. Don't worry too much about that. We'll talk more about that next week when we get into classes. All right, we've done a lot. The lab we're going to work on is finishing out rock, paper, scissors, thinking about it here, and we got to talk about the project. Is it okay if we take a break first, or do you want to talk about the project now so you can leave when you're done? I can do either.
You want to play rock, paper, scissors for it?
Sure. I win, we get a break?
Yeah.
All right. I'm gonna play rock.
Okay.
All right. And we're going on shoot. Rock, paper, scissors, shoot. You win early.
Yeah.
I said I'm going on shoot. All right. You still win though. All right. You win. All right. So what are we doing? We just talk about the project. All right, you want a break? All right. We get a break first. All right. We'll take 10. We'll come back in a little bit. It's hot in here. 7:56. That's pretty close. Take your time. Right, so let me get the lab posted here before I forget that one too. So I'll get you 2 links. We'll have 2 new repositories, right? 1 repository for everything we do. So we'll do one for the lab, CIS 1500, winter 2023, lab 4. This will be our Java template. Alrighty. Oh, I can't even copy that. That's fine. All right. So for lab 4, so again, do next week, 11:59 to 9 p.m. If you need the extra time, go for it. Ideally you get it done before then, but stuff happens. I'm behind on everything right now anyway, so if I can give you another couple hours and that helps, great. That's perfectly fine. These are for your benefit. They don't even count all that much towards your final score, right? If you look back to our GitHub here, it's practice to get you to know where you are. So only 10% of your final score comes from the labs. So I'm happy to go over them in class. If you turn in the right thing, great. That's fantastic, right? You're getting it's participation points essentially here, but use it as a measuring stick for how well you're absorbing the material, right? That sound okay? All right, so please submit the URL. And this is the box I checked wrong. So on some of the classes I did here, it needs to be a text submission, not a file submission here. URL to your repository. Sorry. So using function or using methods, finish the rock, paper, scissors, SCISS, scissors game. All right, let me get that committed here so we have it. Here's week. Hang on. 5 methods. 5 methods. Commit. And here's lab 4. Started. There we go. Nope, not that one. All right, so this was from here. So you are copy paste the whole thing if you want, right? I'm expecting that. If you use other sources, cite your source, but I'm expecting you to start from here. Started in class here. So you're not writing your own methods here. You're just kind of finishing the ones we talked about in class, but the next thing we're gonna do is write our own methods. This is some practice using custom methods here for this one. And there's for that one. All right, and then our next project, then for project number 1. Project 1, so we got 2 weeks for this one here. That'll put us out to the 21st. Now, 6 p.m. for project due dates because I go over them in class. These ones are not participation points, right? These ones are do the work, right? I'm happy to answer questions, get you pointed in the right direction. Tutors are happy to give you tips and pointers. They're not going to solve it for you, but I'm pretty sure they don't tell you to go away either. This will be worth more points. So last project is worth 10 points. This one's going to be worth 15 points. So the projects go up in points because you don't get to forget anything. All the things we've already done, we're still going to keep using in these projects. That's not an up, not going to lie. So usually it works out. So it usually works out okay. Are you just trying to throw those words at me to make me happy? All right. Project 1. He's one shot. All right, so this one will be a little more involved, right, than this idea with the projects. We're doing a little bit more here. So get this in here. Submit the URL to your repository, and a self-assessment. So with the projects, right, I want you to look at the rubric, score yourself, right? Tell me how you did, right? So text submission, there we go, and that goes in projects. Oh, I didn't categorize the other ones, oops. And we'll add a rubric here in a minute. So there's an old game that is sort of a classic now. It's a terrible game. It's really difficult, known as Zork. So Zork is a text-based video game here from a long time ago. And we should be able to play online here. Come on, where'd it go? No, I don't want to download. Did I click the wrong link? I think I clicked the wrong link. This website's terrible. Okay, that's not the link I wanted. This one. Is this the one? One of these links works. Is that the right link? Can you tell I was looking at glasses online based on my ads?
Weather API.
I'm sorry?
I saw an ad for Weather API.
Yeah, we do that too at work. All right. So Zork here is a text-based adventure game. We are going to build a terrible version of this because we're not even to this level yet, and that's okay. Don't worry about it. So Zork knows where you are and tracks that. We're not going to track where the user is. They're just always going to be somewhere. So sort of things that you can do. It says west of the house. This is an open field west of a White House with a boarded front door. There's a small mailbox here. A rubber mat saying welcome to Zork lies by the door. I'm going to say go east. The door is locked. There is evidently no key. All right, I can't go east. Go north. North of the house. You're facing the north side of the White House. There's no door here, and all the windows are barred. Go north. Forest. This is a dimly lit forest with large trees all around. One particularly large tree with some low branches stands here. Climb tree. What do you mean? The tree or the large tree? Climb large tree. Up a tree. You're about 10 feet above the ground, nestled among some large branches. The nearest branch above you is above your reach. On the branch is a small bird's nest. In the bird's nest is a large egg encrusted with precious jewels, apparently scavenged somewhere by a childless songbird. The egg is covered with fine gold inlay and ornamented in lapis lazuli. Is that how you say that?
Sure.
And mother of pearl. Unlike most eggs, this one is hinged and has a delicate-looking clasp holding it closed. The egg appears extremely fragile. Pick up egg. Taken. So you type stuff, and it says things. You type stuff, and it says things. Now, in Zork, it actually knows the things that you've done. We're not going to remember any sort of history here. We're just going to be a terrible game. So every time you say go north, you might say, you went north into the forest. If I say go north again, you went north into the forest. If I say go north again, you went north into the forest. It's not even a game. That's a bit of a stretch here. Okay, but we'll have different directions you can go, and we'll have different actions that you can do. Like climb a tree. Go for it. You climbed up the tree. If you want to give them a nice narrative description, go for it. If you just want to say you climbed the tree, that's great. So this idea is that we're building a terrible text-based adventure game. So this is our terrible text-based adventure. So using methods, we're going to do this sort of thing here. So we're going to have a list of valid choices. And if I enter something that's not valid, like not a verb I recognize, right? If it's not a valid choice, tell them they can't do it. Some sort of message here, right? If they give you garbage, it's fine, right? If I say fly, right? Again, not anything. So they don't get to just do anything they want here. So we'll have given a list of valid, or I don't know, given a set of valid options, 4 directions, and 4 actions. So it could be north, south, east, west. It could be up, down, left, right. It could be northeast, southwest, around the corner to the right. Any sort of whatever directional command you want. Perfectly up to you, right? And then 4 actions. You could be like jump, or fight, or sleep, or hide, or run, or it doesn't really matter. Some sort of things here. Okay, so we'll give them some options. So using a method, get a valid option from the user. Right? So we need some sort of method that makes sure what you get back is valid. Right? If it's not valid, keep them in there. Don't let the method come back and return a value until it is a valid value. Right? Then using methods, display what happens from that action. So go north, we probably want a method like go north. And if they enter go north, we'll call the go north method. It does that stuff. So we're not going to have a lot of code in main. Main's going to be relatively small because main will say, hey, give me an option from the user. And then if it's north, do the go north. If it's south, do the go south. If it's go east, do the go east thing. It won't be very large because most of what's happening will happen in our methods here. Okay. So we also need to track the number of turns the player spends in the game. And there is a secret, escape word that will end the game. So you can say go north forever. The game will never end. You enter abracadabra, and all of a sudden the game will end. Sure. There's some sort of secret nonsense where Zork actually has a storyline. You can win or you could die, that sort of thing. We're not going to do anything like that. So we just have a secret word, right? And the secret escape word is valid as well, right? That should be also a valid choice, right? We're not going to tell them what that is, though, right? So if they enter an invalid option, display their choices or the valid options. So we're going to be helpful here. Display. And I think Zork even does that. I think we can say help. Yeah, help. You can do a bunch of things. This is actually, it was really neat. And this was from 1977. So, like, I find it fascinating. It's older than I am. I know I'm old, but this game's older than me. It's just really interesting. Really hard to win the game without knowing how it actually worked. And, like, so I'm amazed, like, people could solve these sorts of things back before you could just look up solutions online. Like, I don't know. So there's, like, tracking our moves, tracks our score. It does some fun stuff. So it's interesting.
Rooting around dark.
Just trying stuff, right?
Yeah.
All right, so invalid options. We'll give the valid option to the user, display what happens for that action. One of the actions should wound the player. If the player is wounded, they may not travel in any direction. So, and then we're going to include a sleep action that will heal the player, or unwound. Unwound is the wrong word. We'll take away the wound, right? If they sleep, they can travel again. Okay, lots of different ways about going about this. Okay, don't overthink it. You're welcome to overthink it, but try not to overthink it. Right? There's lots of ways we can handle this. So one of those actions, if I had like run and jump and hide and swim or climb a tree, sure. One of them would say, hey, you were running and you tripped and fell and hurt your ankle. Now you're wounded, you can't go anymore. Sure, can't do that. So they're going to be stuck there, and they can't. I'm sorry, they can't do. They're wounded. They can't do anything other than sleep. So the only thing they can do is sleep. Everything else becomes invalid at this point because they're wounded. Other choices are invalid because they are wounded. Wounded. Can't spell. Thank you, spell checker. Spell checker is the best thing ever. My favorite thing. Okay. The number of turns they spend in the game. So this is valid commands are essentially number of turns. So go north is a turn, run is a turn, jump is a turn, right? Go south is a turn. Fuhugu gods is not because it was invalid. It's just nonsense, right? We tell them I don't understand that. So just counting the valid ones. Once I enter the secret escape word, the game ends. Tell them congratulations, thanks for playing, and how many turns they wasted playing the game. Right. Hey, you spent 20 turns in the game. Congratulations, you wasted 20 turns of your life. I don't. Sure. Just trying to have a. Wow. It doesn't recognize congratulations. It was that bad. Because I have congratians. Congratulations. Wow. Come on, computer. Read my mind. So I have an acquaintance who went through a computer science program. One of their specialties was game design. You can like get into a game design track. They took their senior project, which was building out a big game, and then they spent another, I think it was a year working with the team after graduation, and actually published it on Steam. It is called, oh goodness, Forbidden Legacy? Is that right? Hang on. Let me look.
Yes. You have Steam on that computer?
Of course I have Steam. Why would I not have Steam?
Oh my goodness.
Oh, come on, where is it? Lingering Legacy. Lingering Legacy is their game they built here, which was essentially their like senior project that they then polished up and go for it. Go for it. It's not an impressive library. The time in Skyrim here is a little embarrassing. What am I at? 237 hours?
How many hours is that?
237?
Wait. I have easily like 10,000 hours.
I have 7 children and a couple jobs. All right.
expired since 2012.
Yeah. All right.
So I played about
Think
10,000 hours.
think that gets our project here. So let's build a rubric for it. For project 1. Why? Stop grammar.
It's like Xbox or PlayStation, but
Complete or missing.
it's better. It's like.
So we've got 15 points worth here. So I'm going to go about 3 points per category here. We'll have 5 different categories. I think we'll cover everything. So the first one is our method for getting valid user input. Right, so the method that gets the valid user input, right, won't return anything unless it's valid. That's going to be our directions, our commands, and that secret escape word here is a method. So we get 3 points for that one. Yeah.
I have a question about the rubric. The first one we had, it didn't go for me. Like,
Yes, it is not, because D2L sucks.
oh,
It looks like you can click on it,
yeah,
but you can't.
I just typed it in myself.
Oh,
Yeah,
wait,
yeah, you can copy paste it.
Did we have to type it in?
Did you just tell me what your score was?
He didn't even know there was.
No, I didn't even know we had to do that. I just.
You can go and submit just the rubric as like a resubmission, and that'd be great. So the idea is you score yourself.
Yeah.
Okay.
Most of the time, I'm going to take the score you gave yourself. Most of the time. So I'm going to look at your code. If it looks good, you get your score. If I look at your code and it looks funny, then I'm actually going to go and look at it.
Because
Right?
I was trying to.
That's sort of how this works. Okay. Yeah, you can't edit it. It looks like you can edit it, but you can't because D2L doesn't let you do that. I can click on it, but that's not helpful for you. Yeah, so you can just like grab the whole box, copy paste it in, and throw some numbers in there. It's sort of along the philosophy of this thing known as ungrading or contract grading. It's a whole thing, and our teaching and learning center does all sorts of cool workshops about it here. But I'm telling you how I'm going to score it. I ask you to score yourself, and most of the time you get the score you give yourself because you folks are pretty good at this sort of thing. You're like, yeah, I did pretty good at this, or most of you will say, no, I didn't really get this all the way done. And I'm like, great, you did a good job scoring yourself. This is good, right? If you score yourself perfect and I look at your code and it looks wrong, then I'm going to get upset. And then I'm going to look at every one of your projects and grade more harshly because I'll go in the rubric, and you might be more generous with partial points than I am. So, it's sort of a trust here. I assume you can assess yourself and figure out if it works or not, because that's the sort of thing we're doing. You're going to run your code and know if it works. I think that should be the goal. Every so often, people turn in code to me that doesn't even compile, and I get really confused because I have a hard time knowing what to do with that. If it doesn't even run, I mean, I can look at it and be like, it probably would work, but you've got 4 different ways to contact me. You've got office hours you can show up at. You've got tutors you can work with. It'll at least have something that runs, even if it's not complete. At least, right? I think that makes sense. That's the hope. And again, maybe that's why half the people drop or fail the class. I don't really know why. At the risk of sounding like an old person, I've been teaching the class for about 8-9 years now. The content hasn't really changed. I mean, Java's gotten some cool new features, but we basically do the same things. We talk about this, we talk about this, we talk about this. So I sound like an old terrible person. Like, I don't know what's changing here, and I'm trying to figure it out. So, but I think if you know how you're getting graded, I've checked this box off. Yeah, I scored my 3 points. Fantastic. I think that works out well for everyone. There's no surprises here. I don't want surprises. No, that's the goal. All right, so your method for getting valid user input, great there. Having 4 directional command methods, 3 more points there. 4 action command methods, more points there. One of the action commands will wound the player, and not allow them to do anything but sleep. 4 points for that. And then game tracks how many turns spent, and ends when the secret word is entered. Okay, I think that adds up to 15. Does that make sense? And I think that hits all the things we have in here, right? Sleep heals the player. One of them gets wounded. We get actions. We get methods here. That sort of thing. Do we got it all? Okay. Again, not anywhere near as interesting as Zork, because every time you enter Go North, you'll get the exact same message. We don't need to know where the player is. We don't need to know that they went north and they can't go north again. That's more complex than we need. You're welcome to add that sort of stuff if you're bored. And eventually we'll have a slightly more interesting game for our final project. But we got to get there first. So this is actually the first third of class. You folks are doing awesome here. This is 5 weeks of content we've gotten through. We have 2/3 more. right? The next third takes us through more advanced Java topics here. We're going to get into classes. We're going to get into arrays, array lists, and records. We're going to get into file input and output. And then we're going to have the midterm. The last third of class here is writing graphical user interface programs on our final project. So we don't actually have tons more, right? About another one of these sets here for advanced topics, and then another set of this for graphical projects. I have no plans to talk the last 2 weeks. Sorry, is that a question?
I have a question about this project. We can use GUI or not?
For this one, it's just text-based. We haven't got to GUI stuff yet. So we'll do the GUI stuff for our final project when we get there. Yep. Yeah.
So most of the project is pretty much just
We're writing methods for everything. Yep. A method for go north, a method for go south, a method for it doesn't have to be interesting. It's probably just a one-liner.
yeah.
You can put as much code in a method as you want. Your go north method probably says you go north to the forest, and that's okay. That's all it needs to do, right? Some of them will be larger, like where you get wounded. That action's probably going to be a larger method because more stuff has to happen.
So it sounds like pretty, like as far as like it's easier as far as like the last project, I'd say. Like,
There's no math.
What?
There's no math.
Yeah, there's no math. I don't like speak for yourself. Calculating all that stuff. Like, it's just, you know when you go swimming and then all of a sudden you're like, oh, that's too deep. That's how I feel right now.
There's a lot. It's okay. We got some time. Yep.
That's fine, bro. You can delay it, but.
Yep. So we got time. All right, we got the lab to work on. Again, for labs, you are more than welcome. I would love if you guys partnered up on labs and talked together for labs. That's your practice, chance to talk it out with each other. Projects, you can talk about it, but if you're taking notes, you've gone too far, right? Talk about ideas, talk about concepts, talk about thoughts. But if you've got to take notes, you're copying too much from your partner, right? That's our general rule of thumb for that. Okay. Questions, thoughts, concerns? Okay. Awesome. Hopefully we'll get out of here at a better time because I still don't feel so great. So, I spelled wound as wood. I misspelled something here. Let me find it. Wound, wood, wood, would, wound the player. Thank you. There we go. All right. Thanks for catching that. Ancient bags. All right. I think we're good then. So I'll go ahead and end the stream. I'll wander around class. We can work in the lab, get started on the project if you want. We can go from there. I'm going to try and leave by 9 if that's okay. Apologize, but I got to get home and get to bed. I don't feel good. And we'll have some fun. All right. Thanks, folks.